Hello there, and welcome to today's Picoscope session around working with our pressure transducer. So everything pressure and Picoscope. My name's John Parker. I'm Distribution Sales Manager here at Pico Technology in the UK, and I'm joined today by
Steve Smith, Automotive Application Specialist.
So sit back, relax and enjoy this presentation, everything pressure. Okay, let's make a start on our presentation around pressure testing with Picoscope WPS 500. So this is what we're going to run through today. This is our introduction. So first of all, we're going to introduce you to the WPS. What is it and how does it work? Then we're going to take you through some examples about how we connect into the pressure systems within the vehicle. Then I'm going to take you through the different kits that we offer and all the accessories within those kits to hopefully help you understand the correct kit to purchase for you. And then we're going to start to do some practical workings on the vehicle, where I'm going to be joined, of course, by Steve, and he's going to take us through some of these tests on vehicle. And then finally, we finish off with some case studies. And once again, Steve's going to talk you through some real life examples of working with a pressure transducer, just so you get an understanding of where it fits in with garages and everyday use. So that's a brief overview. So let's make a start. So what is WPS? Very simply, here we are with our pressure transducer, and all we do, we take pressure in through one end of the transducer and it gives us the voltage signal out the other. So in the same way that when we view electric signals, we can view pressure against time. So that's how we plot it into a waveform. What pressure can we measure? Well, in truth, anything on the vehicle that is running with a pressure, be that air, or be that things like fuel, so any liquids as well. So anywhere where there is a pressure, we can attach the WPS and we can capture our data. So here it is. How does it work? Well, the first thing to remember is that it's powered by a lithium battery. So it is important, and technicians such as Steve and all of us, you soon get used to the fact that you just need to make sure you've left the pressure transducer charging overnight, so it's ready for you to work during the day. We deliberately have it as a battery, so we don't take too much power from the scope, and it does mean that it is easy to move around the vehicle when we're trying to capture our data. But as it says there, we've got a charge time of about 2 hours, but it will work on standby quite happily for over 8 hours. So all we're doing, like I said, we are just translating that pressure into a voltage so we can view it on our waveform. We have 3 pressure settings. So really important thing to say, and Steve would always tell you that actually this is 3 pressure transducers in one. So do be aware, you will see some more inexpensive pressure transducers on the market, but they tend to be a single range. So what you get with our WPS 500 is 3 ranges. So we've got our 3 modes there shown on the screen. And as we start working on the vehicle, Steve's going to be attaching them and he'll be explaining which mode to use for capturing which data. So we're going to be taking you through that, of course, in more detail. So some words around connecting to the vehicle. So our first part, if you like, in capturing data is going to be how we make those connections. And our pressure transducer kits come with a range of ways. And here we've got there, so we are in the left-hand picture. We are literally simply connecting into the dipstick, and we're just looking at the pressure. So we're doing a crankcase measurement there in cylinder. And then on the right-hand side, just giving you an example of how we might connect into a fuel line. So we've got a various range of adapters and also our sight block, and Steve's going to be running some tests later where he'll show you the sight block in action, but it's a really nice visual way of understanding what's happening within the fuel systems as well. I'm just going to play this short part of the animation, and this is looking at running compression, but again just giving you an example of how do we connect in to a vehicle system. So in the same way that you'll be using gauges in the workshop all the time, we are going to connect in this case, we're connecting in through the spark plug. We've got our standard hose there, and we've got various spark plug adapters in the kits. And there you can see we are building our waveform, and it is simply pressure against time. It's one of our most useful waveforms you're going to capture with anything on Pico. That is our running compression waveform. And we're going to go through that in much more detail as we work our way through the presentation. But what we're trying to highlight here is how you can make connections to all the vehicle systems. And whilst we'll try and capture in this video a few examples, there's a huge amount more. So do remember to look in software, in our guided tests. So hopefully you've watched the previous videos where we work through where you find the guided tests within Picoscope 7 software. And I know Steve picks up from some guided tests in some of his presentations moving forward, I'm sure. Okay, so let's just have a quick look through our WPS kits and accessories. You can view all of this information online on our website, so that's www.picoauto.com. Also now you can download our app onto your smartphone or tablet. So please do that, because that's a really great way to look through our kits and what's available in each of the kits. But we have two main WPS kits, our standard WPS kit, which is there pictured on the left, and our Maxi Kit. And effectively, all the Maxi Kit is a build-up, so we have some extra connections that we can make using our pressure transducer. So just to take you through the base kit, the WPS, what we tend to call standard kit, but it is just the WPS kit. So we've got obviously the pressure transducer included in there as the central point, and then we've got a range of ways of connecting into vehicle systems. Standard compression hose is going to be something you're going to use most often, and then onto the end of that we have a range of spark plug adapters connect in to that running compression. And again, if you're familiar, and I'm sure a lot of you are, of using gauges, if you're used to using gauges, the principle is very much the same, but the data we're capturing is so much more valuable, because of course we are seeing it on the screen, we're capturing that pressure against time, and of course we can save it. So what you see with a pressure gauge, it's lost once you close the system down, whereas with us we can capture the data, hold on to it, save and store it to show your customers, and of course to keep on record for the future. And then we've got a range of fuel hoses that come in the standard kit, so we can start to connect into the fuel, as well as the exhaust adapter. The first test we're going to look at today on vehicle is looking at that exhaust adapter. We call it the exhaust adapter or exhaust hook. And then obviously there's a charging cable, so that is how we charge the cable. So that's a standard USB connection to charge the battery up. And then we have our BNC to BNC cable. So we have a quick coupler, again just to make connections right through to our bleed hose. So the second test that Steve's going to be looking at today is going to be back leakage, so diesel back leakage. And again, so we're using the bleed hose to actually run fuel through the pressure transducers. Like I said, we can use the pressure transducer for, of course, air, but we can also use it looking at fuel. And then finally, the vacuum adapter. So a nice range of adapters and a fairly inexpensive start, and we would consider certainly the WPS kit as an essential tool to add in to your standard Picoscope kit. It's going to be a tool that you're going to use in the workshop every day, and if you think about using gauges and how much and how useful they are, you will certainly find the WPS 500 certainly equally, but probably more useful, particularly in view of the fact that you can save and store the information and the waveforms that you've gathered. So then moving up to the Maxi Kit, it's a slightly larger investment, but it does really allow you to connect in to a lot more vehicle systems. So we have the fuel hose taps, and again, Steve's going to run you through working on fuel systems, and vacuum taps. We have adapter kit A, and adapter kit B in there, and that effectively allows you, so if you've got adapter kits that you use for gauges, so for instance diesel glow plug or oil systems adapters, those two adapter kits, adapter A and adapter B, will allow you to get on most of the kind of more industry standard kits that you've probably already got in the workshop. So a lot of this is about utilising tools that you've already got in your toolbox ready, and allowing you to capture data from those systems. And we also have within the Maxi Kit, we do add in some extra spark plug adapters as well for those perhaps more unusual sizes that you might find useful. So have a look at both. You can see them, like I said, on our websites, that is Pico Auto, as well as on the app, and you can go through the detail there. We also do a range of other WPS accessories. So we have a sight block kit. So like I said earlier, really, really important. We can start to see fuel working through the systems. So if we do start to see perhaps some air in the system, you can see it really, really easy with the sight block. So it's a really nice addition to your diagnostic workstation, as well as diesel glow plug kits. So we do a way to actually connect in to the diesel systems. So like all things Pico, of course, this range will continue to grow, but that's the basis of it. So we'll move on now to working with on vehicle and working with the WPS. So like I said, our first test today is going to be exhaust pulsations. And what we do with these tests, what I try and do is just talk you through the kind of theory behind it, and then I'll pass you over to Steve, and he's going to show you working on these systems direct on the vehicle. So this is exhaust pulsations. And we've put together here, excuse me, we've put together here some animations, and we find with animations we can really show you how you connect into the system, and more importantly how you can see what's going on inobtrusively in the vehicle, and also what that gives to you in terms of creating the waveform. Okay, so we're connecting in, so it's a single channel measurement. So as with all things with WPS, you do just let it cycle through and zero itself before you connect anything to the end, so it gets to our atmospheric pressure. And then we've put that exhaust hook into the back of the exhaust, and we're going to start now to see a waveform. What we are looking for, if everything is working correctly, is a really, really nice, smooth and even wave. I mean, it literally is a wave when we see this, so it's a really classic waveform. Just an example here, and I know Steve's going to do it live on vehicles, so you kind of get to see this twice. We're going to look at what happens if something's wrong, perhaps with compression on one cylinder. How does it disrupt the waveform, and what do we see different? And I know that went away quickly, but what it actually does, we just don't get that nice and crisp and even waveform. And we've also introduced in there a current clamp, and we use the current clamp because we need a reference on an ignition event, so we can work out if there's a problem perhaps in one of the cylinders. By knowing your firing order, you can go back and work out where your problem is in cylinder. So that's exhaust pulsations. Just to run through that again, and what we're going to try and do it for each of these in this presentation, we're going to do three things. We're going to do connect, and for those of you who are familiar with Pico Academy, we always run through connect, so how you make that connection into the vehicle system you're working on. Then how you run and how you capture your data. So how does the vehicle need to be to capture your data? More often than not, we just want the vehicle on idle, but sometimes, we'll take vehicles on road tests to capture data, and we might want to do a snap throttle test. So what we take you through in these slides is talk you through that, and all this information that we're just condensed into these couple of slides is available on the guided tests. So remember, download the software. If you're not already a Picoscope user, please download the software. You can download it for free, and you can look at all of the guided tests, and all the guided tests take you through this, how we connect, how we run, and more importantly, finally, how do we read you know, how do we read the waveform that we've captured? So it's a little bit clearer on this slide, and I know Steve will use the zoom functions to show you even greater detail. That's our, what we call a waveform. I mean, that truly is an absolute wave, so a nice, even flow. That is a good known waveform. And as with everything with Pico, how do we start to understand when things go wrong? Well, we have to understand what's a good waveform for that vehicle system, whether that's the electrical systems, whether that's the pressure systems. We have to understand how it should be when everything's operating correctly, and then when things go wrong, we will see a difference, we will see a disruption, and it's then starting to understand the disruption that can point you quicker and quicker into finding the problem. So that's just a little bit about exhaust pulsations. It's just enough from me for a short while. I'm just going to pass you over to Steve now, and he's going to show you this live on vehicle. Over to you, Steve.
Thank you, John. Let's have a look at the practicalities of this measurement then, which is the pressure transducer inserted into the tailpipe. So we'll capture the pulsations and measure them, and then we'll synchronise those with the ignition pulses. So we'll have a current clamp around ignition coil pack number 1, and then we'll use the firing order to identify the pulses. So let's take a look at the connections. Picoscope connected to the laptop via USB cable. Channel A, that's our BNC to BNC lead, and that goes all the way underneath the vehicle to the pressure transducer inside the tailpipe. Channel B is our current clamp. Now that's going to go around our breakout leads. Now you'll see here we've used the Pico breakout leads to connect our ignition coil connector to the ignition coil pack, which is a perfect location then for us to get our ignition synchronization signal for cylinder 1 using the current clamp. So now looking at software and our setup for Picoscope, pressure transducer is connected to channel A. We go to the probes menu, WPS 500, and it's range 3. We want it on the smallest possible range. On channel B, we've got a current clamp. We're using BNC plus current clamp, so we connect, and the software is already set and configured for us. And we're going to opt for plus or minus 20 amp because of the current that will be pulled by the ignition coil. We've set up a trigger. The trigger, we've set it at 3 amp, and we're going to capture that. We'll actually use the falling edge here, so we'll have a nice clean falling edge on which to trigger for number 1 cylinder. Okay, so if you can start that up, John. Okay, and what we're looking for is uniformity. We want equal pulsations, equal contribution to exhaust gas pulsations from each cylinder. I think we've actually achieved that here. There's nothing wrong with this vehicle at present. If I use these rulers, we can capture the peaks and the troughs, and I'm quite happy that between each firing stroke for cylinder 1, everything is okay pulsation wise. What I'm going to do now is introduce a misfire, so a deliberate fault on cylinder 3, and we'll see how that manifests itself in the waveform. Okay, so you saw there was disruption to uniformity. We'll just go back through the buffer, and there it is. Let's just go back to there. And typically what happens when there's a misfire on a cylinder, we'll have a greater negative pressure above the piston when the exhaust valve opens, and that introduces a deeper pull within the exhaust system, and we can see that there. So if we use the zoom features now, we'll just pull this ruler out the way, the ruler legend, sorry. We'll use our phases so we can actually see the 4-stroke cycle. We'll align that with cylinder 1, and then we'll align 720 degrees later with the same cylinder. We'll zoom in here so we can see a little bit more detail, and then we'll increase the scaling slightly. I'm using the trackpad on the laptop, and we can clearly see here that we have this deep pull, which is from cylinder 3. It was cylinder 3 I'd disconnected. So here we have cylinder 1 expansion stroke. Cylinder 3 will be firing here, so this will be the expansion stroke for cylinder 3. And here between 360 and 540 we'll have that additional pull from the misfire because of the negative pressure above the cylinder on cylinder 3. So if we just zoom back out again so we can see that repetition. There we have the uniformity for cylinder 1 is disturbed because we have this big pull on cylinder 2. Cylinder 3 was where the big pull is. It's conclusive that we have a condition that we need to investigate on cylinder 3. Not always that clear, certainly with multi-cylinder engines with complex exhaust arrangements. You'll be looking for a signature waveform from a known good vehicle, and then when you have a misfire, comparing it with the data that you've captured.
Thanks, Steve. That was great. Okay, moving on to our next test. We're going to look at injector back leakage. So pressure transducer, one thing I should say, we are limited in terms of the pressure we can put through the system. So we can't do the high pressure on diesel, but we can do what Steve's going to show you now, injector back leakage. And once again, I'm just going to show you through the animation, and we're going to go through connect, run and read. So we're giving you an overview of how you work connecting to this system. Okay. Short animation. And it is a really nice way to see things. It's not always easy to see when we're working live on vehicle. So this is our diesel injector. Everything working connection correctly, sorry, I should say. So we're using 2 channels. The first one is our reference channel. So we're just using our current clamp on ignition event, just so we've got that reference on the waveform. And then we are connecting into the fuel. And remember, so we've got a cable tie around there, so we're allowing the fuel to run through the pressure transducer, and you'll notice at the bottom we've got a bottle collecting the fuel. So this is the same, you'll be used to seeing kind of spill bottles. You'll have done the same test with that. So we can do the same thing electronically. Again, what's the advantage? Yes, of course, you know, the spill bottles are really easy to see visually, but you can't really save it. Okay, you can take a picture, but for this, we're actually saving live data and we're seeing it, and we can look at the waveforms, we can zoom in and out, so we can analyze it much easier. And there's our standard waveform. These animations do run on a little quick, but what I should say, they are on our website, so if you look on our YouTube channel, so that's Pico Automotive, you can see all of these, and we run through each of the tests that we do on there. And here's an example. So what happens when things change, when something disrupts, as I said earlier, we will see a disruption in the waveform. We don't get quite such a crisp and even pattern. So it's the same as you would see in a spill bottle. You would see more fuel in one compared to the other ones, and we're just doing the same thing, but it's an electronic version. So we're just going to run through that connection once again. So like I said, it's a 2-channel capture. So we've got channel A is going to be our ignition reference. So we would use our 60 amp clamp for that. And then we've got our pressure transducer connected to channel B, and we are just running that into the fuel line. And remember our spill button, but you have to close the button on the side of the pressure transducer. And like I say, Steve's going to run you through that straight away on vehicle, so you'll see that live. Once again, it's a test that we capture on idle, so you've just got to have the test running, and just to remember, a reminder that whenever we're capturing everything with Picoscope, we need Picoscope 7 software running before we can capture any data. So make sure the software is ready and running, turn the engine on, get it on idle, then we're going to start to capture the data we need. Like I say, what are we looking for? We were looking for a nice and crisp, again, that nice kind of even waveform. And if we've got an issue with that, again, because we've got our current clamp on ignition, so injector number 1, we could start to work out if there's a problem with the waveform. We can work out which cylinder we've got the problem in, and then you can start to look further for situations there. So that's a very quick overview in terms of injector back leakage. And I'm going to pass you over to Steve, and he's going to show you that live on vehicle now. Over to you, Steve.
Thank you, John. Looking at injector back leakage now. So the style of connections and how we actually intrude, because it is an intrusive test. So we'll take the final pipe from the injectors, so all 4 injectors in a line with a 4-cylinder, of course. We'll feed that into the WPS pressure transducer, and then we'll ensure that the transducer is open so it can drain straight through and then into a capture bottle. It's important that we have this system open because a lot of pressure will be generated if we introduce a restriction. In addition to that, we'll also have a current clamp around injector number 1. So that will give us the synchronization of these pulses, and we'll be able to identify any potential problems with each injector. So let's take a look at the connections. So Picoscope via USB connection into the laptop. Channel A is BNC to BNC to our pressure transducer, and channel B is our current clamp, and that is connected around injector number 1. So there's our synchronization signal. Now, as far as the pipe work goes and the arrangement for the back leakage, so final injector on this vehicle is cylinder 4. This pipe comes off cylinder 4 injector. Remember to clamp off the feedback from the rest of the diesel system. So this one is clamped so we have no leakage here. We've got this going into our sight block. You could use a T-tube if you wanted to, but it's great. The sight block works really well for a number of reasons. One, it's blocked here, so the diesel has to pass through here. Also, we can actually purge, so we can see any bubbles that we've got in the system during the initial purging or running of the engine. Sometimes it helps to actually tip this backwards and forwards so you can remove the air and you'll see that dissipate through the sight block. Remember, we must keep the pressure transducer open, so we must have a passage through the measurement chamber and out through the drain port. And we do that with a cable tie wrapped around the purge valve here. And then finally, the pipe will pass through into receptacle here where we're collecting the diesel from our spill test. And as you can see, we've approximately 5.5 to 6 mil there from our test. So our software configuration for back leakage, we're using pressure transducer on channel A, and we've gone for range 2 because depending on the system, this pressure will start to increase. So range 2 plus or minus 690 millibar is fine for this vehicle. And then on channel B, we've got the current clamp, and that's wrapped around injector number 1. Solenoid injectors here, and we're going to use a trigger on a rising edge of about 4 amps. That should cover us comfortably. So if we start the vehicle, so there we'll see the pressure starting to rise. So if I just pull a ruler down, you'll see that pressure building, and we can also see formations of pulses. We'll just let that build up. And then we'll change the scaling on here, so we can actually monitor those pulsations and see how they relate to each injector event. Let's try that once more. We'll go up to a factor of 5 and then pull air down. There we are. Okay, switch off, John. So once again, we're always looking for repetition and uniformity. So if we pull these rulers down here and just have a look at how each trough and each peak aligns. Yeah, so all in all, something slightly different here. Let's bring in the phase rulers so we can actually look at the 4-stroke cycle, and we'll align that with the final or the main injection event there on cylinder 1 and there as well. And we can attribute then these pulsations. So here we have a dip during injection event number 1, number 3, number 4 and number 2, and then a recovery. So these pulsations, I'm happy that they're even and that there's nothing that concerns me at this point. So the next stage would be to free rev the engine, and if need be, a road test as well, so we can actually try this on the road and see what happens under excessive pressure, whether we can actually get a different value or indication that one injector is leaking back excessively under full load.
Thanks, Steve, that's great. Just a reminder here, so I've just put up on the screen and all of these links, there are a few links as we run through today's presentation, and we will put them, they're all down there in the bottom if you look at the description below in YouTube. You can click on all the links. We have a load of videos that Steve's done and the other guys have done over the years, particularly looking at pressure. So please remember, you know, to get over onto YouTube, subscribe, and look out for new videos as they come along. So that's just a reminder that's there, and Steve takes you through this test once again in that way. Okay, negative priming. So Steve's going to run you through this one. We're not going to do this one live on vehicle today, but Steve's going to run you through it because he just wants to go into the real kind of details and the nuances, looking at negative priming with WPS. So I'm going to pass you over to Steve for this one.
Thank you, John. So we're going to look at negative priming using the pressure transducer. So we'll have to go intrusive. We're going to insert the pressure transducer into the fuel line, and we'll also include the sight block. So we'll run through the animation on the next slide, and we'll talk about exactly how we take this measurement and the procedure involved. So here we have a 4-cylinder diesel engine. No issues in terms of fuel delivery at this point. We're going to use the sight block and select the relevant adapter to suit the hose size. We'll disconnect the fuel hose from the fuel filter. So this is from the tank to the fuel filter. Switch on WPS and make sure it's zeroed and connect. And now, of course, prime the diesel, because we don't want to run this vehicle without diesel. So prime through, you'll see the fuel pass through the sight block. That's the beauty of the sight block. We can check for aeration and contamination. Connect WPS to the scope, and now we can start the vehicle. So notice there that we are below atmospheric pressure. The dotted line is 0, that's our atmospheric value. Run the engine, and now we close the stop tap. So notice now how we're pulling a negative pressure, because we've actually got the pump pulling on a blockage. We open the tap and then we switch off the engine, and notice there that we are still below negative pressure. So that is very important. So let's have a look at a genuine fault, and I've actually had this fault on a vehicle where the delivery line is corroded and air is allowed to enter the pipework. So we've now got aerated fuel. So you see there we can capture it in the sight block. And when we close the stop tap, we actually do start to pull negative, but you'll probably find the vehicle will cut out at that point in time. We open the stop tap, switch off the engine, and we're back to atmospheric pressure almost immediately. Now that is a fault on the vehicle. We should be able to hold a negative pressure when we turn the engine off with the stop tap open. So how do we connect? Well, we set up WPS as per the guided test. We've got instructions that will take you through this procedure with pictograms as well. Remove the fuel supply from the high pressure pump from the fuel filter housing. We run to capture data for this test. The engine must be running, of course. We want this engine at idle. That's assuming it will run. If you spot air in the sight block whilst you're trying to crank and run the engine, you've pretty much diagnosed already where the issue lies. Wait until there's no air present, so if you've purged the air, then that's good. Connect the WPS and then start capturing. This pictogram here demonstrates the setup for negative priming. If this was positive priming, we would change this around because we'd want the stop tap on the outside of the block. Remember, with positive priming, when you close that tap, be aware, because depending on fuel system, that is now deadheading the pump, and that will, or has the potential to, increase pressure. So be familiar with your fuel system. And here is that good example. So here we start below the 0, so we start below atmospheric pressure. Engine running, so we start to pull a greater negative pressure, sorry. We close the stop tap, so now we have a blockage, a restriction. We pull right the way down to negative 700 millibar, so that is a good example of a pump and a sealed fuel system. We open the stop tap. If we don't open at this point, the vehicle is going to cut out. Open the stop tap, notice the recovery here, the disturbance, and then we get to where we were before, predominantly just below atmospheric pressure. Turn the engine off, and then we could leave Picoscope running onto the next slide, onto the next buffer, sorry, and we should see it maintain below atmospheric pressure. If that starts to creep up, indication of a leak.
Okay, thanks Steve, that was great. So the final test we're going to look at live on vehicle today is going to be running compression. Arguably the best of our pressure tests, and a really great waveform in terms of if we really want to understand the health of the engine and if we've got an issue with compression. This is a really simple data to get hold of, but the detail we can see is huge. I'm going to pass you over now to the king of compression, Mr. Steve Smith. Over to you, Steve.
Thank you, John. So we'll now look at running compression using the WPS, and we'll go through the animation that describes the procedure and what to expect. So we have a 4-cylinder engine, and we're going to look at in-cylinder measurement, and it's cylinder 1 that we're choosing here. So as you would for a conventional compression test, remove the spark plug. The difference here now is we're going to select an adapter that suits the spark plug. What we don't want to do is exceed the reach of the spark plug because we end up damaging the engine. So compression hose and the correct adapter into the cylinder. Switch on the pressure transducer. Make sure it's open to atmosphere, and that will 0, and now connect to the hose and connect to Picoscope. Now if we focus on the graph view here in the bottom right hand corner, see how we're coming up now on the exhaust stroke. Now we go down on the intake, so we start to pull a negative pressure. Now we come back up on compression. And that is the 4-stroke cycle. There's our compression and expansion pocket, back down on the intake, and then we'll start to come back up on compression. So because there's no valve inside the hose, we will actually see the rise and fall of pressure. Now let's have a look at a faulty engine. So image on the right is an exhaust valve that's opening correctly. Image on the left is an exhaust valve that's failing to open, or certainly open fully. So let's just watch that again on that left hand side. As the camshaft lobe comes round, notice there's very little throw of the exhaust valve. So here we come up on the compression, back down on the expansion stroke. Now here we're actually coming up on what looks like another compression, half a compression tower, then back up on the conventional compression. There's a normal compression tower, symmetrical. On the exhaust stroke, we're generating almost as much pressure as we did on the compression stroke, and that repeats. So we can clearly see there we have a restriction or blockage in the exhaust during the exhaust stroke. Here we have an exceptionally contaminated filter such that we cannot draw air into this engine. So as we come back down on the, we go up on the compression, notice we're low on compression by comparison. We come now down on the intake stroke. Look how deep the intake stroke is by comparison to the expansion pocket there. And then a low compression. Remember, if we can't pull air in, we can't compress, so we end up with a low compression. A big deep intake pocket there, and then a very small or short compression. So revealing the 4-stroke cycle will help you to diagnose what area of the engine to concentrate on prior to dismantling, because we do our diagnosis before dismantle. So let's have a look at a case study, and we actually saw this event. This is a true event that we saw in the animation. Let's have a look at it closer view. So here we have our compression tower, which is symmetrical. Notice we've got this rounded expansion pocket here. There is no clearly defined exhaust valve open event. And then during the 180 to 360, where our piston is coming up on the exhaust stroke, we're actually generating what looks to be another compression. This is about 7 bar. If you look, that is exactly half a compression tower. And now at this point here, there is a sudden dramatic drop down during the intake event, and this is the intake valve opening. So this customer complaint was engine runs uneven, there was a popping via the intake. Well, as we can see here, we are generating this compression stroke in effect during the exhaust stroke, and when we open the inlet valve that 7 bar has to go back into the intake. That would be the popping that the customer can hear. So we do have uneven running engine, popping via the intake, a diagnosis before dismantling. Now the beauty of this is, this style of fault you would not detect with a compression gauge, because if you put your compression gauge into the engine, you will have peak pressure. We just build and build and build on compression strokes. So this clearly would get missed without using a pressure transducer. Okay, moving on to another one. This is a case study. This is an engine non-start. So same procedure again, pressure transducer into the cylinder. What I want you to focus on is this area here. This is the exhaust valve open event, which is typically around about 150, 160 degrees before bottom dead center. We can see it's actually shifted over. Our exhaust valve open event is retarded. Notice here at this point, way after the 360, we're starting to pull on a negative pressure here. We're starting to drop below atmospheric. What's happening here? We've got the late closing or the retarded closing of the exhaust valve. Both valves are closed momentarily, so we start to pull a negative pressure because we are coming back down on the intake stroke. Then it shoots back up to near atmospheric because our inlet valve is opened. So this is totally retarded for both exhaust and inlet. And look how late we close the inlet valve. We are probably heading up toward 650, maybe a little bit longer, 650 degrees after TDC. It's going to be a very short compression stroke. It's remarkable that we do generate that pressure. What we can safely say here, both our exhaust and our inlet valve timing is retarded for this engine. And the fault with this, the engine was actually timed correctly, but the crankshaft had spun within the crankshaft pulley. So although the pegs and the timing alignment was correct, the crankshaft was allowed to turn independent of the pulley assemblies. So from a diagnostic point of view, non-intrusive or reasonably non-intrusive, conclusive data. So now we'll look at in-cylinder pressure testing, and it's possibly one of the most least intrusive and yields the most results for the amount of time spent. So much diagnosis can be carried out and so much revealed about an engine, and in particular activities within each individual cylinder. It's no different to a conventional compression tester. Obviously match the hose and the adapter to the vehicle spark plug that you're working with, connect the pressure transducer, and then use the guided test, because the guided test will set up everything for you, and then we'll capture the in-cylinder measurement. Let's have a look at the connections. Our connections then for the WPS 500 pressure transducer in cylinder requires the compression hose and the correct spark plug adapter. So we ensure that the adapter is tight, and more importantly we make sure that it does not exceed the length of the spark plug. Okay. Once that's connected, hose straight into the cylinder, and it is finger tight. Connect to WPS, switch on WPS, allow it to auto range. We want range 1, and then it's BNC to BNC cable into channel A of Picoscope. So starting with the guided tests, pressure transducers, and it's WPS 500, a number of options here, but we're interested in cylinder pressure at idle. Load the settings file or the guidance settings file. Well, we'll go for guidance settings file because that includes connection diagram, how to perform the test, a typical example of what a good one should look like, and then as you scroll down, of course, you've got the waveform library if you're looking for an exact example from another vehicle. So we'll minimize this. There we are, we're all set to go. That's ideally what we should capture. Our pressure transducer is already set to range 1, so we'll run the start button. Now probe mismatch has appeared because it's saying probe is not found, sorry, probe expected is WPS 500, and say probe found is probe not detected. That's because this is not a BNC probe, so it cannot detect. We have already connected a pressure transducer to channel A, so we are happy to run with found probes. Okay, John, if you can start the vehicle. So there we are, there's our pressure waveform, and immediately notice that we're actually over ranged. So we need to go up one range, and there we've captured our pressure peaks. We'll pause the software and we can switch off, John. Thank you. And let's start with the analysis of this waveform and see just what is revealed about how this engine is performing. So we'll just minimize this. We'll bring out the phase rulers, and we'll start with our 0 degrees at peak compression, and then 720 at peak compression again on the same cylinder. So starting from left to right, we're looking for uniform compression towers. We don't want to see the compression towers leaning. Let's have a look at peak pressure. Now peak pressure there is 7.8 bar. Now that is not a fault. Remember, if you were to see 7.8 bar on a compression gauge, you would think that this was low compression. Well, remember, this engine is running at idle, so the throttle is closed, hence we can't pull enough air in, so our pressure drops. Next, we're looking for the event here, where our exhaust valve opens, and how we detect that. We'll pull this ruler down here, the signal ruler, and we'll place this on 0 bar. Anything below that line is negative pressure. From 0 to 180 degrees, our piston is travelling down the cylinder on the expansion stroke. And approximately this point here, we could probably be a little bit more accurate, round about there, our pressure starts to rise even though the piston is coming down on expansion. That is the approximate point of our exhaust valve open. Next, we're looking for 180 to 360. We don't want to see any high pressure here. That would indicate certainly that we have a blocked exhaust or a problem with maybe restriction through the exhaust system, maybe valve obstruction, whatever. The next area is difficult to determine because around about 360 there are a number of events that take place. There'll be the exhaust valve remaining open, the inlet valve open because that will be our overlap period. Then there'll be a point where our exhaust valve closes. They'll also have a point where our piston changes direction at the 360 mark because we'll go from coming up at TDC on exhaust, and then we'll be starting to move back down on the inlet. What we can safely say is at this point here, where we achieve our maximum negative pressure on the intake pocket, is where our exhaust valve is truly closed. Carrying on from here then, the next point we're looking for is our approximation of inlet valve close, where our compression starts to rise. And you'll be surprised just how far after 540 degrees that will be. On this engine, approximately there, 601 degrees after TDC on compression, we close our inlet valve and then we start to build our compression peak ready for the next firing cycle. The waveform library is your get out of jail, if you like, for a comparison for a known good, and then you'll be able to overlay one with the other and determine whether there is a problem with this engine. It is possible to have a problem on one cylinder only in terms of valve timing, and yet all other cylinders be okay. This truly is a powerful tool.
Thanks, Steve. That's great. Okay, so we're coming to the end of our presentation today. And I'm just going to take you through where to go and find some more information working with Pico. Of course, working with the pressure transducer, working on pressure, but also all the other things that you may well need to use Picoscope for every day in your workshop. So first of all, as we are talking about pressure, there is a series of videos on our YouTube channel. WPS, so if you look at playlist, we have a playlist for WPS, and you'll see in there it'll give you more examples than we've got time for today in terms of working, capturing with data, and more importantly understanding the waveforms that you see, and also looking out for what goes wrong. So when waveforms are disrupted, what has been the cause to that, because of course that's where the real skid is. So like I said, go on YouTube and remember to subscribe. I mentioned it earlier, we also have a Picoscope app, so there's some training on there and some good case studies as well. We've put a couple of case studies on there looking at pressure, so download it now, available for, like I said, smartphone or for tablet, works well on both. And just a reminder, so we have got a YouTube channel, so it's Pico Automotive, but also we have a forum. So we have a very active forum on our website. So you just go Pico Auto and then click into the forum. Become a member. You create your own username and password on there. And just to remind you that if you've got a username and password on our forum, it's the same that you will use for the waveform library. We haven't talked specifically about the waveform library in this presentation, but it's a really huge source of information. So if you want to know what a good known waveform is, particularly around the vehicle that you're working on, well worth getting on the waveform library. Reminder that the waveform library, like I said, you need your forum login, but you also need to be online, and it's one of the only things you need to have Picoscope connected to gain access to. Well over 7,000 waveforms now. And then there's some essential links here. So that's the link, and like I said, they're all listed below on this YouTube video. So if you go onto our website, go onto products and just click on pressure sensors, you can go in there and find all the information about the different kits and all the accessories within those kits. There's also a section in our auto website, which is a library. So we've got a whole library of information. Particularly useful in there would be our A to Z, and our A to Z talks you through the jargon, if you like, of Picoscope, but also diagnostics. So it's a really useful source of information. As well as in there's a huge range of case studies. And the case studies are really important because you can start to then envision how you fit Picoscope diagnostics and also Picoscope pressure diagnostics into problems that you see every day within the workshop. So please take some time to look at the case study section in the library there. And you can filter that down, so you can just look for pressure case studies, so you can start to see how you would use the pressure transducer within the workshop. Reminder that if you haven't already downloaded the software, go to Pico Auto, download our latest version of Picoscope 7. It's a really, really powerful tool. And you can download it for free. If you haven't yet purchased Picoscope and you're just watching this because you're interested, you know you need it for the workshop, but you really don't know where to start, please download the software now for free. You can run it in demo mode, and you can start to understand how you're going to use Picoscope in your workshop. And of course, all of those guided tests, I know we've been talking about it a lot through today's presentation, but all the guided tests are also in there in the software. So a huge amount, wealth of information for you to pick up on and build your own knowledge and understanding. And then there's some links there for YouTube. So our playlist around WPS and pressure, and a couple more there as well. And that link there for support is for support if you have an issue with the tool, or if you need some help from us, you know, analysing data. Please have a look on there, and all the connections, all the details of how to contact Pico are within that section as well. Okay, so we come to the end of our presentation today. Finally, we're just going to talk a little bit about Pico Planet. In August of 21, the IPCC, and if you're not aware of what the IPCC is, that is the International Planet on Climate Change, and this is 600 of the top scientists from around the world who get together and they try and present to politicians the situation with climate change. At Pico, we've long since understood that we can no longer continue to burn carbon at the rate that we are. And we take that seriously. So we've spent the last 3 years actually trying to understand our full carbon footprint as a business. So it's everything we do operationally in terms of building the product, as well as how we work, how we ship goods, how we run our buildings, everything that we do within the building. So now we've got a really, really good understanding of our carbon footprint. And you join us here in the UK only a week after we've seen 40-degree temperatures in the UK for the first time in history. So I think everybody can see that things are changing, and we all have a responsibility, no matter how big or small our business is, to reduce our greenhouse gas emissions. That IPCC report shows us that it's quite clear now we have to reduce all of our global greenhouse gas emissions by 50% by 2030. So, you know, we're now getting towards the end of 2022. We don't have long to make a big change. And as a business, we are committed to doing that. So here are our targets. So we'll be net zero carbon by the end of this year, and that means that we understand now fully what our carbon footprint is, and you can view all of this. We have a Pico Planet page on our website, so we now understand what it is. We will start to offset at the end of the year all the greenhouse gas emissions we've made. We are then working towards zero landfill, so we won't be sending items to the landfill, so that involves us looking all the way back through the supply chain and trying to reduce the amount of excess, particularly packaging, that we create in the supply process. Making big changes in the way we do business travel, so we are switching much more of our meetings away from face-to-face, from distribution sales managers like myself travelling around the world and visiting with customers. We do a vast majority of that online. Of course, we have to travel sometimes, but we make sure we do that as responsibly as we can. When we need to visit trade shows, for example, where, you know, it's an opportunity to meet many people from all over the world, so rather than us create lots of separate flights going to different countries, we meet in one central location. That does indeed reduce our greenhouse gas emissions, and where we do have to take those decisions to fly, we of course will offset that as part of our net zero carbon commitment. We're also have had a program here over the last year where we've super insulated our buildings, and it's made a huge difference to our energy consumption, as well as now putting solar panels on the roof. And again, if you look on our website, on our Pico Planet page, you can actually see live how much energy we're generating from our solar panels, so it's really worth having a look. And then finally, you know, hybrid working, it's clearly a part of our post-pandemic life. It's great to be in the office when we can and to see our colleagues, but we've also found that working from home is efficient as well as part of our mix. So we are working towards 50% of our work being from home, and that saves us, believe it or not, somewhere in the region of 200 tonnes by just changing to hybrid. So we're working towards it. We will get to a 50% reduction in our greenhouse gas emissions by 2030. We're not there yet by any stretch, but by understanding where we are today, we are certainly moving towards that for the future. Okay, that's it for pressure testing. I think I'll just go over and join Steve, and we'll finish up then. Okay. Well, that's it for this short session around working with Picoscope on pressure. Like I said, my name's John Parker, Distribution Sales Manager here, and thanks so much to Steve for showing us everything on vehicle.
Well, yeah, I hope you found something valuable in there. It really is a powerful tool, the pressure transducer. Remember, it's 3 transducers in one, and you saw the results with today's testing.